Hey, good morning, everybody. Today we're going to be moving into the skeletal system chapters, and these will include chapters 6, 7, and 8. We're going to cover each chapter individually, but today we'll be beginning with chapter 6, and really just beginning with the first half of chapter 6. Now, if you want to follow along in your lecture book, I'd recommend looking at page 174. You'll find some really good, helpful images as well on pages 175, and moving into pages 176 and 177, you'll find some additional helpful information in pages as well. As we talk about this chapter, there are going to be a few things that we primarily focus on. So we'll talk about what the functions of bones are, which by this point should not be brand new, being that we've already covered the skeletal system in lab. A lot of this information should be reviewed for you at this point. Maybe hearing it a second time around will really help you understand and get a really good foundation on the information that you want to know regarding bones in our skeletal system. We'll also talk about how bones are classified based off of shape. Again, a really good image for that would be page 177, a really good picture there to help you out. We'll also talk about the specific anatomy of bone tissue, again going a little bit more into detail than what we talked about in lab. As we go a little bit further along, we'll talk about bone from a microscopic standpoint. We've already seen a little bit of this in lab as well, as we looked at the central cavities and we looked at the lacunae, or central canals, I should say. All of these are things that we've kind of investigated. We looked at lamella. These are, again, terms that you should be a little bit familiar with, but we will cover those again in this chapter as well. We'll then talk about what bone is comprised of from a chemical standpoint, again referring to the organic and inorganic components of bone tissue. Again, very, very important to understand. So this will really be kind of the topics that we cover in today's first video lecture. Now, there will be a second portion of this as well, and as we move to the second portion, we'll talk about what happens when our bones grow. How do our bones develop over our life? What happens as our bones begin to maybe break down or deteriorate as we get older? What happens if a bone is broken? How does that bone get repaired? That's going to be something very essential, very important. And again, we'll cover that in a second separate video. We'll also talk about bone disorders. So again, diseases that can negatively impact our skeletal system and bone tissue. And so we want to understand kind of why this matters. Now, again, when we talk about understanding our skeleton, it is a very important function of our body for protection, for support, but again, understanding that we want to be able to investigate bone anatomy so that we can determine what happens when our bones are being remodeled throughout our lives. Our bones do not remain the same as we transition from a young child to an adult. Even as we become elderly, our bones are remodeled and changed throughout our lives, so we want to be able to understand that. If someone has a bone disease such as osteoporosis, again, understanding the skeleton will help us understand those diseases, which are fairly common. Some of those things that do impact our system as we begin to age and our system slowly may begin to decline. We'll also be able to anticipate problems. So, for instance, if there's any type of pelvic dimension situations that might affect labor or delivery, maybe people might start to experience arthritis as they begin to get older. Maybe you start to see ligaments being torn as people begin to age or doing certain activities. So we want to be able to understand these things. And again, getting our ins and outs of the skeletal system is really the best way to be able to do so. Again, I've already kind of alluded to this, but joints are very important. Many of us, as we begin to get older, we may realize our joints don't feel like they used to. And as we continue to age, sometimes that continues to progress. And we want to be able to understand that to the fullest. So, again, this is why this chapter is important. We're going to talk about these topics throughout. But again, getting a really good outline of just understanding why this chapter is important, what things that we want to know about. Keep in mind, on page 173, there's a really good flow chart for you. That flow chart allows you to break down bone and skeletal tissues. Again, there's a really helpful video that you can watch, again, in your study area. So you want to be sure that you feel comfortable understanding bone tissue, understanding the skeleton, understanding, again, the functions and the support of our body. And then also later on, we're going to talk about the specifics of joints. And all of those things will go hand in hand. So the first thing that we're going to look at is the function of bone tissue. Now, before we talk about bone, keep in mind cartilage is a very essential part of our skeleton as well. We will talk about cartilage throughout the chapters, but again, you can find some really good information on cartilage on page 174. So on page 174, it does a quick recap of hyaline cartilage, fibrocartilage, and elastic cartilage, which are the most common types of cartilage. It also talks about the growth of cartilage as well, and there's a really good table there that allows you to compare cartilage and bone. So again, page 174 is kind of a one-stop shop for cartilage information. I wouldn't encourage you to read over it because it will be important that you know about cartilage as well. So as we talk about bones, we're going to see that bones actually have about 7 different functions. And the first of these you'll probably consider pretty obvious. These are functions that most people can relate to, they can think about and understand. However, some of the later functions we're going to see are things that you may not always think about in regards to your bone and skeletal tissue. So support, pretty straightforward. We need bone tissue to support our body. Without it, our muscles will have nothing to attach to, and we'd just be a lump of tissues, essentially, with nothing really to hold our body upright and give us that support. Also protection. In chapter 1, we learned about body cavities such as the thoracic cavity and the pelvic cavity and the cranial cavity and vertebral cavity. These again are formed by bone tissues that provide protection in so many different ways. Anchorage, again, anchoring the body, giving our skeletal muscles something to attach to. Again, as we talk about this information, you can begin to see this in your book on page 175 and 176. But again, anchorage, again, allowing our muscles to have these bones to pull upon so that we can bend and provide movement, which is, again, very, very essential for our survival. Now, at this point, you probably, again, are pretty much, commonly have been used to hearing those first 3 functions, but now we get to some of these secondary kind of underlying functions that are still very vital and very important. We have mineral storage, which again, our bones are very good at storing things like calcium and phosphate. These minerals are stored kind of in a deposit fashion, and then again, they can be withdrawn to provide nutrients for our body. So again, really important to think of our bones as a key place for mineral storage. We also have a very, very important process that happens in our that happens in our bone tissue called hematopoiesis. And this happens particularly in our red bone marrow where our blood cells are formed. So again, when you talk about blood as a connective tissue and you learn about red blood cells and white blood cells, well, where do they come from? They come from our red bone marrow, which is found in our bone tissue. So again, really, really important. Essentially, we could not live without our blood. So again, we want to understand how important bone is in regards to being able to produce our blood and blood cells. We also have the ability to store energy, store fat in our bone tissue in the form of yellow marrow, and this is what we refer to as our triglyceride storage. So again, this yellow marrow is a really good source of energy found in the cavity of long bones. So we're seeing red marrow for blood cell formation, yellow marrow for fat storage. These things are greatly beneficial for our body. And then last but not least, hormone production. We do have limited but still true hormone production that comes from our skeletal system, from our bones. So again, these are things that you may not even think about or consider. You may have, again, thought about support, protection, and anchorage, but again, the last 4 are still very, very vital, important functions. They are necessary, and we want to give, again, we got to give bone tissue and bones as an organ their credit. They do so many things for our body that we often just kind of overlook and don't think about. And again, you can see this information in your book on pages 175 and page 176. So again, as we talk about these functions, we see some images here that are going to kind of help us understand these. Again, like I mentioned, support, giving our body the framework that it needs to be able to move around and stand upright and have, again, attachment for muscles and tissues. We again see protection, like I mentioned. We have the cranial cavity, which is important for protecting the brain, the vertebral cavity, which protects the spinal cord. We also have the thoracic cavity, or the rib cage, that protects our lungs and our heart, those organs that are found in that chest region. So again, a lot of areas of protection that goes on from our skeletal system. Like I mentioned, we have skeletal muscles that will attach our bones to tendons. So again, we want to keep this in mind. When we talk about our muscles contract and pull upon our bones, which allow us to bend in so many different movements and angles and different ways. So again, this anchorage is very important. And like I mentioned, these first 3 functions are pretty much straightforward. These are things that you will probably think about irregardless of taking a anatomy and physiology class. But as we go a little bit deeper, we find some additional factors as well. These factors again include mineral storage, like I mentioned, calcium and phosphate, which is stored inside our bone tissue, can be released as needed. We also see red blood cell formation from our red bone marrow. Really good indication of the red bone marrow you can see here. We see the yellow marrow here. That again is for energy or nutrient storage in the form of fatty tissue. And then last but not least, we have hormone production, which again is going to be really, really important as well. Now, I'm not asking you to know all the ins and outs of hormones just yet, but understanding that your bones do help generate hormonal response or hormone production, still very important, something that's going to be significant for us to understand. So we have some images here again that kind of help support some of those facts that were mentioned previously. Again, movement, support, definitely key to remember that we have our blood cell production there, storage of minerals. I mean, the list goes on, but you start to kind of build a case that bones are very, very important organs. And again, keep in mind, an organ is made of many tissues. We're going to see that with bones, we have blood vessels, we have bone tissue itself, we have cartilage typically. You might have some other connections there, so it is technically an organ, and you don't want to forget that these are very, very, not always exciting organs, but very important organs nonetheless. So let's talk about how bones are classified, and again, our shapes will be key here. The shapes will really tell us how we can separate bones into different categories. Now again, we can break down bones from a classification standpoint based off of their location. For instance, we always divide the skeleton into two main components, those being the axial skeleton, which you can see highlighted in yellow here. The axial skeleton really includes the skull, the vertebral column, and then the bony thorax or the rib cage. And then we also have the appendicular skeleton. So when I hear the word axial, I think of the word axis. If you think about the earth rotating on its axis, it's kind of down the center, down the core. So again, you think of the axial skeleton as the center or core of the body. The appendicular skeleton are going to be the appendages that are attached to this axial skeleton. And again, the appendicular skeleton will include the upper limb and the pectoral girdle, the area that allows the shoulder joint to be formed and allow the arm to attach to the body. And also the lower limbs and the pelvic girdle. Again, this girdle here allowing the attachment of the hip, and again the lower limbs as we make our way down to the ankle and feet region. Now we can also classify bones based off of their shape. And again, this is what I was alluding to earlier. We have those four general shapes that bones will typically fall under. And those are listed as we can kind of see here. Long bones, which are longer than they are wide. Some of the easiest examples are going to be in the arms and in the upper leg, the femur and the humerus. But don't forget other bones like the clavicle. Technically will still be a long bone. All the bones that are found in your hand, not your wrist, but your hand, these are long bones. Same thing as your feet, not your ankles, but your feet, these are long bones. So when you think of most of the bones of our appendages, our arms and legs, most of those will be in that long bone category. We then have short bones, which are kind of isolated to certain areas of the body. We really only find these in the ankle, the kneecap, and the wrist, the kneecap and the ankle. Sorry, pointed to the wrong areas there. But again, those are really the only areas where we'll find those short bones. So they're not as common as many of the others. We also will see flat bones, which are like the ribs, all the bones of the skull. The sternum's a great example of a flat bone. The scapula as well, a great example of a flat bone. And again, these are really, really thin bones, as we see sometimes curved, like you might think of with the ribs. And again, just seeing another category. Last but not least, we have those bones that I kind of describe as the misfit bones. They don't fit in any particular group, so we kind of put them in their own category, and these are what we call the irregular bones. These bones are really the bones that we find primarily associated with the vertebral column. So all the 24 bones that make up a vertebral column are irregular. The sacrum and coccyx are also irregular. We also see that as we look at the other areas such as the coxal bones or hip bones, so don't forget the coccyx or the tailbone is different from the coxal bones. Again, the coxal bones are the hip bones. The hip bones are made from fused bones, the ilium, the ischium, and the pubis, and so these are irregular bones as well. If you start hearing about fused bones, again, those are typically a really good indicator that you're dealing with irregular bones. Even the hyoid bone, which you can't really see here, but is down in this area region here, is also a really great example of an irregular bone. So, what we're going to do now is move specifically into bone anatomy. We talked in general about the functions of our bones for our body. We talked about how we can divide the skeleton into axial and appendicular, and then we've also talked about how we can classify bones based off of shape. So now we want to go directly into the bone anatomy, and again, you can begin to look at this information on page 177, even some really helpful images as you move into pages 178 and 179 as well. So as we look specifically at bone anatomy, like I mentioned, we want to remember that bones are organs because they contain multiple tissue. We have bone tissue, which is osseous tissue. We have nerves running through our bones. We have connective tissue there surrounding and supporting our bones. We have muscle tissue there. We have epithelial tissue there, and we have blood vessels. All of those things are connected to bones. So that is officially what makes bones an organ. And don't forget that the simple definition of an organ is having multiple tissues that have a common function or goal. So that's really the key factor that we see here when we think about bones. And like I mentioned, bones are not always considered exciting, but there's more going on inside our bones than we often think about and often give credit to. You typically hear phrases like, dried up bones and those things. And yes, sometimes that is true, but for the most part, we want to remember that bones are a living organ. They have living tissue and carry out very important functions that are critical, essential to life. Now, when we start to look at a bone more closely, we begin to see that the external outer layer is what we call compact bone. And again, it appears smooth and solid to the naked eye. If we take a look at our image here, we can see the compact bone on the outer edge region here. And typically when we look at bone, especially from an external perspective, we're really seeing that compact bone. That's really the typical idea of what we think of when we think of bone tissue. But we want to understand that there is an internal network, kind of a woven web-like network, that we call spongy bone tissue. Sometimes you hear it referred to as trabecular bone. And so we have this honeycomb network or trabeculae network where there's a lot of kind of open spaces inside here. Now again, it kind of looks mesh-like or web-like. Again, you can see a little bit more about this in your book if you'd like to. Typically, like I mentioned, you can find this on pages 177 and 178. And when we talk about this, one of the things that we'll see is that the compact bone is primarily found in the shaft region of our bone tissue, which we're going to look at more closely. The spongy bone tissue is typically found in the ends of our bone tissue. So again, when you get to the ends of the bone, which we'll see referred to as epiphyses, those are going to be typically where you see the spongy bone tissue located. We're going to see that's going to be really, really important for how joints are formed and also how red bone marrow is located. And then again, when we talk about our compact bone tissue, we're going to see this makes up kind of the middle portion of the bone. For long bone specifically, makes up kind of that shaft region to give the bone their strength down the center core areas. Now again, when we talk about short, irregular, and flat bones, sometimes they are a little bit different as far as how the spongy bone and compact bone are positioned. These are thin plates of spongy bone covered by compact bone, so almost kind of like a sandwich you might think of. You think of the compact bone being the bread, and then in between, maybe the meat or the peanut butter and jelly is the spongy bone tissue. So again, it's kind of sandwiched between. A really good image of that you can see in your book on page 178. Now again, they're going to be covered from the outside and inside with connective tissue membrane. So again, really, really important for keeping in mind that bones are organs, and we're starting to see multiple tissues involved and included here. You will still have bone marrow inside the trabeculae, so we can see the trabeculae here providing open spaces for the red bone marrow to be situated, which again, red bone marrow is very, very important for our blood cell formation, which we just saw from our function list earlier. We do have hyaline cartilage that will be there as well. That hyaline cartilage will typically cover the ends of the bones where bones will articulate, and that word in this case, articulate, just means meet with. So again, where bones meet with other bones, there will be cartilage there to reduce friction and ensure our joints can flow and move pretty fluidly. You don't want bone rubbing on bone, very, very painful, something that we always want to try to avoid. So again, when we talk about long bones, they do consist of both spongy and compact bone. And like I was mentioning, long bones will have a end, which we can see here. So this is the end of the bone. The end of the bone we're going to see is called epiphyses. I can always kind of remember this because epiphyses start with an E, and then end starts with an E. And then we have the shaft, which again makes up the middle portion of the bone, the longest kind of section of the bone, which is typically going to be made of our compact bone tissue. So again, you will see a difference in location for long bones in regards to spongy bone and compact bone. So here's a really good opportunity for you to begin to kind of practice when it comes to labeling your bones, understanding how bones are situated. Again, in this case, we can see the epiphyses, again, at each end of the bone. In this case, we're focusing on the humerus or the arm bone. So the epiphyses here. Notice with the epiphyses, we have our cartilage here. Again, you see the term here described as articular cartilage. So you may think, oh, wait, you said there's only 3 types, right? There's only fibrocartilage, elastic cartilage, and hyaline cartilage. Well, in this case, articular cartilage is describing the cartilage based off its location. This cartilage is located in an area where bones will articulate, where bones will meet. So again, these are referring to cartilages that we'll typically find in our joint regions. Now again, we see the diaphysis, which is making up the shaft. And again, the shaft that we see here is going to be primarily made of our compact bone tissue. So again, spongy bone tissue internally. Yes, you do see the external compact bone, but internally here there would be spongy bone tissue. Internally here there would be spongy bone tissue. However, internally here there's going to be pretty much just compact bone tissue. There will be a cavity on the inside, and that cavity is going to be where marrow is kept. But again, we will see a slight difference of, once again, compact and spongy bone tissue locations. So like I mentioned, we have the diaphysis, which is the shaft, made of that compact bone tissue. Inside you have this cavity, and that cavity is going to be filled primarily with our yellow marrow. So just like we have a difference in where the compact bone tissue lies and where the spongy bone tissue lies, there's also going to be a difference in where the yellow marrow lies versus the red marrow. The red marrow is typically going to be found in the epiphyses, so again along the ends in that area where it's kind of spongy. And then the yellow marrow is going to be found again in the diaphysis, again where that area is going to be surrounded and protected by compact bone tissue. Now as we go a little bit further along, like I mentioned, we have the epiphyses, which are the ends of the bones, and these again are regions where bones will articulate with and meet with other bones. So we do have to think about that and keep that in mind as well. We do also have coverings of our bone tissue, which is the periosteum, and this is kind of a, pretty much a connective tissue layer that surrounds and wraps around our bones for protection. Internally, which lines the internal cavity, we also have the endosteum. So again, these are connective tissue membranes that surround and protect our bones, and there's really good information for you in your book on page 178, but also some really helpful images for you in your book on page 179 as well. As we continue to talk about long bones, we can have a really close look here now. Notice again the connective tissue that we see here surrounding our bone. So again, this connective tissue will be again that periosteum that we can see listed and indicated here. We also see the yellow marrow inside the cavity. So again, we're starting to be able to notice some really, really unique features of long bones. Again, notice how there are blood vessels and nerves that radiate all throughout our bone tissue. When we talk about bones are highly vascularized. I always kind of say this, but if you think of cooking maybe a piece of chicken that has a bone in it versus a piece of chicken that does not have a bone in it, the piece that does not have the bone is going to cook faster because the bone actually requires longer time to cook because it is such a vascularized organ. Now again, there's going to be arteries that run through our bone tissue providing nutrients to our bones. We also have veins that run through our blood tissue as well, so both of those are going to be running through the central canals. And like I mentioned, we also have our marrow here in the middle, which is going to be important. In this case, we can see it clearly being represented as yellow marrow, and again that yellow marrow in the cavity surrounded by the compact bone tissue, again spongy bone tissue at the ends of the epiphyses. And again, don't forget about the connective tissue surrounding that periosteum, which is very, very I would say important and critical as well. We also have, and I don't know if it's going to be labeled here, but you can see this in your book, we also have what's called preparating fibers or Sharpie's fibers. And these are kind of like glue. They almost kind of look like a spider web, so to say, but these are kind of like a glue that hold the connective tissue and attach it to the bone for protection. So again, a lot more going on in bone tissue than you might have originally realized. We also, of course, have nerves that are going to be running through our bone tissue as well. We don't want to forget that. Those nerves help us detect, pain and sensation inside our bones whenever joints are being stretched too far. Those are things that we can also determine and pick up and learn more about as well. So let's talk a little bit briefly about bone markings. Now, when we talk about the external surface of a bone, typically you want to understand that they're rarely going to be completely smooth. They're rarely going to be completely featureless. There's typically going to be some type of projections or indentations on our bone tissue, and these can be very, very important. Now, for my class, I'm not going to ask you to specifically know bone markings in detail, but you do want to know what they are and in general what they are used for. However, many of you will be going into dental hygiene or surg tech where you're going to be learning specifically about bone markings even as nursing or EMT or EMS workers. You may be learning about bone markings, so these will likely be important for you later in your career field. However, right now we're just going to be generally introducing them. Now, typically you have projections, part of the bone tissue that kind of juts out. You feel over the bone, it feels like a little raised area or a bump. These projections are typically going to be sites for muscle and ligament attachments. So we'll see terms like tuberosity and trochanter. Most projections will start with the letter T. So that's something you want to keep in mind. Most projections will start with the letter T. Again, you can begin to see some of these in your book on page 180. Like I mentioned, tubercle, tuberosity. I'm not saying that all of them will start with T, but most of them do. You also have surfaces which help form joints. So again, these are going to be areas like the head or the facet or the condyle. These are going to be really, really specially shaped areas that allow bones to kind of fit together in really, really unique ways. Again, allowing joints to form, which of course provide us with various degrees of movement. Last but not least, we have depressions, which are kind of indentations or ridges. Sometimes these can be openings, a complete opening in the bone as a whole. In general rule of thumb, depressions will typically start with the letter F. So things like fissure or foramen or fossa. Again, I'm not saying that every depression will start with F, but many of them do. So again, these provide very, very important attachment for our muscles and ligaments. The ligaments are designed to hold bone and bone together. We have tendon attachments that will hold muscle to bone. We again have the ability to form specialized joints, and we again have passageways that allow blood vessels and nerves and other sites of attachment to truly occur. Like I mentioned, a really good table in your book that you can find on page 179 and 180. Again, I'd highly recommend just glancing at the table. I'm not asking you to know every bone marking of every bone, but in some instances, later in your career field, you may need to know these, so it may not be a bad idea to go ahead and start beginning to make yourself familiar with bone markings and their importance. So what we're going to move into now are some of the microscopic aspects of bone tissue, and you can begin to see this information in your book on page 181. So again, really on page 180 and 181, we begin to start looking at bone tissue a little bit more in depth. We've covered bone again from a functional standpoint. We've covered bone again from a locational standpoint. We've even seen some aspects of classifying bone. So now we're going to be going more into the microscopic anatomy of bone. And again, a lot of this will somewhat relate to what you've already seen in lab, but some of it will be new because we did not really go into the detail of bone cells, which we will talk about and investigate here in lecture. So what we have here are some of the unique cells that we find in bone tissue. We have the osteoprogenitor cells, and these are going to be cells that are found in the periosteum and endosteum. So these are the cells that are found in the connective tissue that surround our bone and I would say line our bone internally. These will eventually turn into osteoblasts, and we're going to see that osteoblasts have the really important role of forming our bone matrix. These again are going to be what we call the building cells of our bone tissue. So when you hear that word blast, in this case blast, building, these are going to be cells that are designed to build our bone tissue, highly active as we're maturing, as our bone tissue is growing. We're going through those puberty phases. Osteoblasts are constantly cranking out and producing bone tissue. However, once our bone tissue has been formed, it then only needs to be maintained. And that maintenance of our bone tissue is performed by the osteocytes. So I almost think about it, for instance, if you're having a house built, you have your contractors that are out there building the house, but once they're done, they don't come back and come to your house every day, right? I mean, yeah, they do need to be there to build it, but once they built it, then you can probably do a little home maintenance yourself. Now, of course, if there's a serious issue with your home, yes, you're going to call in help. But again, you're not having the contractor show up every day to help you maintain your house. So again, these osteocytes are there to maintain the house, monitor the bone matrix. It's already been built. We just have to keep it up and running. That's really the job of the osteocytes. You then have bone lining cells, which are flat cells, which again are found on bone surfaces where bone remodeling is not happening. Again, these are typically areas where our bone tissue is fully grown and not really going to be changing very much. You can see a little bit more about this in your book on page 181 as well. And then last but not least, you have the osteoclasts, which are really, really important cells that are sometimes needed to help break down bone tissue. So they kind of are the opposite of osteoblasts. Sometimes these will be referred to as a bone resorbing cell. They'll resorb bone tissue, and this could be really important for bone remodeling or when bones are damaged and need to be repaired. So we're going to see, again, really good images in your book on page 181, really good description of each of these types of cells as well. Here's the image that you can see on page 181. Again, from left to right, we have the osteogenic cell, which is that stem cell, which eventually gives rise primarily to osteoblasts. Osteoblasts, again, are for building bone tissue, so blast, bone growth, and building going together there. Again, the osteocyte, which are really the primary cells that you hear about and think about and learn about. These again are found in the mature bone matrix, and they are there to maintain the bone tissue. No need to really build bone tissue. And then again, we have osteoclasts, which are important as well. Typically do not become activated until other points in life, but they can be activated whenever bones have been damaged, whenever bone needs to be resorbed or remodeled. These are the cells that are once again taking care of that task and carrying out that activity. So what we're going to do now is take a look at the microscopic anatomy of bone in a little bit more detail. And again, you start to see images that hopefully remind you of things that you've already seen in lab. You have this really good picture of our bone tissue here. So we have the central canal, we have our lacunae here. Again, our lamella indicating the rings or the layers. Think about peeling an onion back and you have these different layers. A really good artistic view of the same image can be found here. If you want to see this image in your in your lecture book, you can do so on page 183. Similar image is also available for you in your lab manual. I don't have that page number handy right now, but again, your lecture book, page 183, will be a really good good page to look at to start, seeing more detailed investigation of the internal microscopic anatomy of our compact bone tissue. So again, we have these osteons, which are basically this region, and this region includes the central canal, the lacunae, and then the lamella around it. So we have this osteon, or this unit, that again is found in our bone tissue. When we talk about those, again, they contain the bone cells, those osteocytes, which are down inside the lacunae. We just talked about the osteocytes, but again, you cannot see them because they're deep down within this cavity. We have the central canal, which is going to be important again for our blood vessels and nerves to pass through. So this darkened area here, which also correlates to the area or the section that we can see here. We've already talked about how blood vessels and nerves are very essential for providing nutrients and communication for our bones. So we see an area where they're going to be, once again, held as well. We also have perforating canals, which are canals that kind of run transversely. So if you think about cross streets, or maybe a street running perpendicular to another street, then that's kind of the way that you want to think of perforating canals. Now again, we'll see Volkmann's canals and other canals as well. Those are still in that same category, in which they allow communication not only in a vertical fashion, but also in a horizontal fashion as well. Alright, so as we continue along and we begin to talk about the microscopic anatomy, or continue to talk about the microscopic anatomy of bone, we now get a chance to talk about a really unique area that we call trabeculae. And you'll hear this term in other places as well. This trabeculae kind of has a lot of indentations, and these really kind of help set up an internal network inside bone tissue that really allows your bone tissue to resist stress. Now again, because our bone tissue needs to be strong, and again needs to be able to withstand pressure as we bend and we move, maybe as we take a hit, or maybe in a car accident, so to say. This doesn't mean that our bones will never break, but this trabeculae network is really, really beneficial for giving our bones an assistance in strength, basically as we see here, to defy resistance, or to defy stress, which is really, really beneficial, really, really important for us as well. Again, we start seeing the bone marrow, which is found in the holes between the trabeculae. And again, that bone marrow primarily in the epiphyses will be red bone marrow. Again, this is very important because this is where our blood cells are formed. And again, this includes red blood cells and white blood cells. So again, if you want to look more closely at this information in your book, you can find it as you start moving along pages 186 and 187. And then even seeing some more information as you start going into more detail about hormonal regulation and bone growth as you move to page 188. Again, if you want to see some internal images of bone, again, you can see some really good images on pages 178. And then also, like I mentioned in your book, you can begin to see some of the pictures of the really, I would say, ins and outs of bone tissue as you look on page 183. So again, as we continue on, we want to understand that nutrients will diffuse through these tiny little canals to the actual bone osteocytes. And again, these are the cells that again are maintaining the nutrients. So we have a lot of activity going on in here. And again, you may not have really thought about all this kind of action happening inside your bones, but again, understand that the bone cells are down inside these cavities, and there's capillaries that are going into these areas that are providing nutrients for the cells that are there within. We're going to now switch and talk a little bit about the chemical composition of bone. And again, you can begin to see this in your book on page 182. So we're going to see that bone tissue contains organic and inorganic substances. Maybe makes you think back to chapter 2, right? We talked about organic versus inorganic molecules. So we're seeing this kind of applied again today. And again, we're going to be talking about this information as we talk about organic versus inorganic. We want to understand that again, when bone is healthy, it's very, very strong. It's really durable. It lasts us our whole life, and it bears our entire body weight. So we want to remember that for the most part, bone is really strong and sturdy when it is healthy. What we're going to see, however, is that when we start losing a lot of those organic and inorganic substances, as they start to decline, or maybe they are not, I would say, picked up by the body properly, we start to see bone tissue become weak and brittle, and that is essentially when we start to see bones breaking, which typically is, not good. And if you've ever broken a bone before, then you probably have personal experience of kind of what I'm referring to or talking about. So when we talk about bone, we get a chance to see that healthy bone is about half as strong as steel. If you've ever seen or heard about steel being used, then we have a pretty good idea of how strong that is. So think about something naturally in our body being half as strong as steel. And it's really good for resisting compression. Again, having really good tensile strength. So when we talk about compression, again, being maybe sandwiched or pushed upon. When we talk about tension, maybe being pulled, it resists that pulling force. And again, really, really beneficial for providing protection and again, providing the support that our body so much needs. So we see the compression really indicating being pushed together like I mentioned, tension, being pulled apart. Our bone tissue can bear both of those forces, and also, again, bear what we call the load weight. Again, our body is very much resting upon our skeleton, so it has a unique ability of being able to do those things because of these organic and inorganic substances. So when we talk about the organic substances, these include the bone cells and the osteoid. This is basically the bone matrix itself, which is where we have the ground substance and the collagen fibers. So when you think of organic components, think of components that are associated with living tissue and living cells. Again, the cells are living. The fibers are not, but the fibers are made by the living cells, and this is basically a general component of what we discussed when we talked about connective tissue. You have the cells secreting the extracellular matrix. That matrix is primarily going to be made of fibers such as collagen fibers. So again, when we talk about the organic components, we're talking about the living cells and their products, the things that they are designed by or the things that they are actually producing. When we talk about inorganic components, these are things like calcium and phosphate. These are the mineral deposits that allow bone to resist compression. And essentially, these are, again, though, one of the things that we talked about was that a function of our bone tissue is storing of minerals. So again, when we talk about these inorganic components, these are minerals that are stored within our bone tissue. These, again, allow it to resist compression. So again, if you want to read more about these, you can. You can see this in your book on page 182. It tells us that about 65% of our bone tissue by mass is made of inorganic substances or mineral salts. Again, most of it being calcium phosphates, and these are really, really tightly packed. They're kind of like crystals. Again, the collagen fibers kind of help hold them in place. And again, because of the mineral salts they contain, bones pretty much will last long after death. I mean, if you've ever seen, maybe a skeleton of maybe a dead animal, or maybe just seen movies or TVs of a body, and that bone tissue is still remaining behind. I mean, even after all the muscle has deteriorated, all the skin is broken down and deteriorated, because of these inorganic components, bone tissue kind of stays around for a long period of time. And in a lot of cases, they kind of maintain a good bit of their shape and a good bit of their appearance. They can even tell us sometimes if somebody had any ailments. If you kind of study those bones after the fact, they may be able to tell you about things such as arthritis. So again, not saying you have to know all of that, but you just kind of start to get a little insight on how bones are so sturdy and tough due to their inorganic components. So we will stop there for today. When we pick back up in our next video, we'll talk about what happens when bones grow, how our bones are remodeled and changed over our life, and how bones are repaired. We'll also talk a little bit about some other aspects as well. So again, just keep in mind that we're going to be breaking this first video lecture down into kind of 2 different lectures. And again, we'll come back with our second portion here in just a few days. Thank you so much for tuning in and listening, and I hope that each and every one of you have a blessed day.